It all begins with a simple thought, a question you need answering. Maybe you want to know what the weather will be like in London tomorrow, or you need some help with your child's history homework about the Tudors. You open your computer, tablet, or phone and navigate to the familiar Google homepage. There, you see a clean white page with a colorful logo and a single inviting search bar. This is where your journey starts. You type your question into this box. It could be a full sentence like, "What is the capital of Australia?" Or just a few key words, such as London weather tomorrow. Once you have finished typing your query, you press the Enter key or tap the search icon. In that single moment, a remarkable process is set in motion. Your question, which is now digital information, is packaged up and sent from your device. It travels through your home's Wi-Fi or your mobile network, embarking on an almost instantaneous journey across the globe. Think of it like posting a letter, but instead of taking days to arrive, your message travels at nearly the speed of light through a vast network of undersea cables and land-based connections, all heading towards one of Google's enormous data centers. The search bar is more intelligent than it looks. As you type, Google often tries to guess what you are looking for. This feature, known as autocomplete, offers suggestions based on popular searches made by millions of other people. It can help you save time and even correct spelling mistakes as you go. For example, if you start typing how to bake a cake, Google will probably suggest how to bake a cake before you have even finished. This initial step is designed to understand your intention as clearly as possible, ensuring that the answers you get are as relevant as they can be. This entire first stage, from thinking of a question to sending it off into the digital ether, happens in the blink of an eye. It feels effortless, a seamless part of our daily lives. We rarely stop to consider the incredible technology that is waiting to receive our simple request. Whether you are searching for a recipe for spaghetti bolognese or the opening times of your local library, that initial act of typing and sending is the crucial first step in unlocking a world of information. Your question is now on its way to be answered by one of the most powerful computer systems ever built. When your search query leaves your device, it doesn't just go to one single computer. Instead, it is directed to one of Google's many massive data centers scattered all over the world. These are huge, secure buildings filled with thousands upon thousands of powerful computers, known as servers. Your question is sent to the data center that can respond the fastest, which is often the one located closest to you. Think of these data centers as giant post offices, but instead of sorting letters and parcels, they sort through digital requests from billions of people every single day, working tirelessly around the clock. Inside these data centers, your question is received and the real work begins. The system doesn't understand your question in the same way a person does. Instead, it breaks your query down into keywords. If you searched for best dog-friendly parks in Manchester, the computers identify the key concepts: best, dog-friendly, parks, and Manchester. The system is programmed to understand synonyms and related ideas. So, it knows that parks could also mean green spaces or recreation grounds, and best implies you are looking for highly rated or popular locations. This interpretation is vital for finding the most useful results. This process of understanding your query is incredibly sophisticated. Google's algorithms have learned from trillions of previous searches to better grasp what people truly mean. They can understand context. For example, if you search for Jaguar, Google needs to figure out if you mean the car brand, the animal, or perhaps even the old video game console. It looks at other words in your search and your recent search history to make an educated guess. This is why the results for new Jaguar Speed are very different from the results for Jaguar Habitat. It is all about figuring out your intent. Once your query is understood, the request is sent out to another part of the system, the index. This is where Google's real magic lies. The initial servers that received and interpreted your question have done their job. They have prepared your query for the next stage, the search itself. It is like a librarian receiving a request for a book. First, they must understand exactly which book you want before they can go into the library's vast collection to find it. Your simple question has now been translated into a precise command, ready to be executed in the next fraction of a second. Now that Google understands what you are looking for, it needs to find it. To do this, it searches through its own enormous digital library, which is called the Google Index. This isn't the internet itself, but rather a copy of it that Google has made. Special automated programs, often called spiders or crawlers, are constantly traveling across the web from one link to another, 24 hours a day. They visit new websites, check for updates on existing ones, and record everything they find. This information is then meticulously organized and stored in the index, which contains trillions of web pages. Think of the index like the catalog system in a colossal library, the biggest library the world has ever known. When the spiders find a new web page, they don't just note its address. They analyze everything on it: the words, the titles, the images, the videos, and the links. They pay special attention to keywords and topics. So, if a page is about baking chocolate cakes, the index will list that page under terms like baking, cakes, and chocolate. This makes finding relevant pages later on much faster. Without this pre-organized index, searching the entire internet in real time would be impossibly slow. So when your search for help with maths homework arrives, Google doesn't search the live internet. It searches this incredibly well-organized index. The system instantly pulls up every single page in its index that mentions maths and homework. This initial list could contain millions or even billions of pages. Finding all the pages that contain your keywords is the easy part. The real challenge, and what makes Google so special, is figuring out which of these millions of pages are the most helpful and should be shown to you at the very top of the list. This whole process of searching the index is astonishingly fast. Even though the index is unimaginably vast, containing more information than all the physical libraries in the world combined, the search takes just a fraction of a second. This is because the data is stored and organized in a very clever way, spread across thousands of computers that work together. It is a bit like having thousands of librarians searching through different sections of the library catalog all at the same time. They quickly find every possible match before moving on to the final, most important step: ranking. Finding millions of possible answers is one thing, but showing you the best ones first is what truly matters. This is where Google's ranking algorithms come into play. These are a complex set of rules and calculations, a secret recipe that looks at over 200 different factors to decide which pages are the most trustworthy, relevant, and useful for your specific query. It is not just about matching keywords, it is about judging the quality of each page. The goal is to put the most helpful result at the very top, followed by the next best, and so on. One of the most famous factors in this ranking system is called PageRank. The basic idea is that if many other reputable websites link to a particular page, then that page is probably important and trustworthy. It is like a vote of confidence. If many different history professors all recommend the same book about the Tudors, you would probably trust that it is a good book. In the same way, Google sees links from other sites as recommendations. Pages with more high-quality links pointing to them are often ranked higher in the results, as they are seen as more authoritative. Beyond links, Google considers many other signals. It looks at the words on the page to see if they truly match your query. It checks if the website is secure and easy to use on a mobile phone. It considers the freshness of the content. For a search like latest football scores, you want results from today, not from last year. It even uses your location to provide more relevant results. For instance, if you search for best pizza, Google will show you pizzerias near your current location, not on the other side of the country. All these factors are weighed together to create the final score for each page. Finally, after all this lightning-fast work, understanding your question, searching the index, and ranking the millions of results, the process is complete. The top 10 or so results are packaged up and sent back across the internet to your screen, all within less than a second. From asking about the weather to getting homework help, this incredible journey from your keyboard to Google's data centers and back again happens in the blink of an eye. It's a complex dance of technology that makes finding answers to the world's questions feel simple, instant, and effortless.